We have content of this unit. We have mechanical speed torque characteristics of various types of load and drive motors, braking of electrical motor, DC motor having shunt series compound motor, single phase and three phase induction motors. Let us begin with characteristics of DC shunt motor. We have three motors. Among that three motors, let us begin with characteristics of DC shunt motor. In this DC shunt motor characteristics consisting electrical characteristics and mechanical characteristics. Electrical characteristics say about torque versus armature current characteristics, then speed versus armature current characteristics. These two are electrical characteristics. Then mechanical characteristics depends upon speed versus torque. So each and every characteristics of shunt motor having these three classification like torque versus armature, speed versus armature current and speed versus torque characteristics. Okay, these three classifications going to be set or organized this DC motor proportion of characteristics. Come, let's go with torque versus armature current characteristics. First of all, let we know about DC shunt motor. DC motor having private or separate field winding. That separate winding says this motor as a shunt motor. We have three classification, shunt motor, series motor, compound motor. While we are seeing the shunt motor, the connection wise after supply one inductance are connected parallel of the DC motor. Okay, this is shunt motor connection. Series motor means after the armature one inductance are connected. Compound motor mean both shunt and series winding connected across the DC motor. This is three category of motor. That first let us see about shunt motor, DC shunt motor. DC shunt motor represent first private parallel windings connected. Okay, this is DC shunt motor. In this DC shunt motor, we begin with torque versus armature current characteristics. Like armature current going to be reach the motor, the torque will develop depending upon the armature current. Okay, in case DC shunt motor, the field excitation current is constant and the supply voltage is kept constant. Therefore, flux per pole will be constant. This is torque versus armature current characteristics. Here, torque always proportional to the armature current. Second thing is speed versus armature current characteristics. Here, a motor speed always depends upon the constant voltage minus armature current and armature resistance. So, we can get speed proportional to V minus IaRa. Okay. This categories will say gradual reduction of speed because when this armature speed is rise up, it will proportional to V minus IaRa. When the speed will decreases, that condition also proportional to V minus IaRa. So, three categories must be following towards of speed torque characteristics. Third one is speed versus torque characteristics. It's called a mechanical characteristics. Here, speed is always a proportional to the current, armature current. Torque is directly proportional to the armature current. Meanwhile, the speed always inversely proportional to the torque. Okay, so when the torque gradually rise up, speed will reduced. The graph says speed versus torque always inversely proportional to the depending condition. Next, we have to see types of electric braking. We have three types: rheostatic or dynamic braking, plucking or current braking, or reverse current braking. Third one is regenerative braking. These three braking are very important braking to control this mechanical and electrical load. First one is electric braking of DC shunt motor. In the regenerative braking operation, the motor operates as a generator while it is still connected to the supply. Here, the motor speed is greater than the synchronous speed. Mechanical energy always converted into electrical energy, the part of which is returned to the supply and rest as heat in the winding and bearings. Okay, that means while you are giving to the supply of shunt motors or shunt winding, the shunt winding excited. When the shunt winding excited, the motor gets more fluxes from exciting winding and it just ready to operate. This is the electric braking of regenerative. Then dynamic braking. This dynamic braking method, motor is disconnected from the supply. The field connection are reversed and the motor is connected in series with the variable resistance R. So that separate resistance, connected resistance notified here. Third one is plucking. The plucking operation can be achieved by changing the polarity of the motor, thereby reversing the direction of rotation of the motor. This can be achieved in AC motor by changing the space sequence, and in DC motor by changing the polarity priorities. Okay.